Hi, everyone. Last time we talked about this tour from 0 degrees to 90 degrees, basically through quadrant 1. Now we're going to extend to other quadrants. All right, so what are the related angles in other quadrants with similar trig values? We're going to talk now about reference angles and what I call brothers. You can call them sisters or siblings, but for convenience, I'll call them brothers. Okay, so the reference angle for a non-quadrantal standard angle, so an angle in standard position, but not a quadrantal angle, so not including 0, pi over 2, pi, 3 pi over 2, and so on. A reference angle for a non-quadrantal standard angle is the acute angle that its terminal side makes with the x-axis. All right, so let's get straight to the point. Over here, we have this 30-degree angle. I like to label the intersection point between the terminal side and the unit circle with the angle measure. Here, this point corresponds to 30 degrees or pi over 6 radians. The reference angle for this 30-degree angle is 30 degrees. The reference angle for any acute angle will be itself because, well, by definition, the reference angle is the acute angle that the terminal side makes with the x-axis. For an acute angle, the reference angle is always itself. But 30 degrees is also the reference angle for the 150-degree angle. The terminal side hits the unit circle at this point, and again, the terminal side makes a 30-degree angle with the x-axis. Likewise, for 210 degrees, we have a 30-degree angle between the terminal side and the x-axis. For 330 degrees, we have a 30-degree angle between the terminal side and the x-axis. So all 4 of these angles here I call brothers because they share the same reference angle, 30 degrees. Some books might call these coreference angles, which actually does make a lot of sense because we could say that coreference angles share the same reference angle in the same sense that coterminal angles share the same terminal sides in standard position. So we can think of these brothers as coreference angles more professionally, although the term coreference angle is not quite standard. It makes sense, but it's not quite standard. And frankly, I think the term brothers is more evocative. All right. Again, brothers, my term. You can call them sisters or siblings, or if you're a mathematician, coreference angles. These are angles that have the same reference angle. Now, again, brothers have to be non-quadrantal. Quadrantal angles are different. In fact, I can tell you right now, quadrantal angles will have basic trig values that will either be 0, 1, -1, or undefined. The trig values, the basic trig values for a quadrantal angle will be these guys. All right. Anyway, brothers are really for non-quadrantal angles. So you won't see these values actually. Except, no, actually tangent. You do see that tangent of 45 degrees is 1, for example. So with some exceptions for tangent, for the most part, you don't see these for non-quadrantal angles. You do sometimes see these for tangent and cotangent. Okay. Now, how do we determine these various brothers? By the way, brothers include coterminal twins. For example, you might notice that the point here for 330 degrees is the same point as for -30 degrees. And the reason is that these two angles are coterminal, and they share the same intersection point here. So brothers include the coterminal twins. Actually, twins is a misnomer. Every angle has infinitely many coterminal angles. So twins is too restrictive. Every angle has infinitely many coterminal angles. All right. Back to brothers. All these are brothers, coreference angles. Now notice here in radian measure, there's a nice pattern. For example, pi over 6 here, right? That's acute. That's an acute special angle, pi over 6. What's his famous brother in quadrant 2 in radians? And this is one reason why we may prefer radian measure to degree measure. You might think you prefer degrees right now, but actually radians make it easier to hop from quadrant to quadrant. Who's the famous brother for this angle in quadrant 2? 5 pi over 6. 5 is 1 less than 6. How about quadrant 3? The famous brother in quadrant 3. 7 pi over 6. 7 is 1 more than 6. What about the famous brother in quadrant 4? That's positive, because negative pi over 6 is also pretty famous. But the famous positive brother in quadrant 4 is 11 pi over 6. How is 11 related to 6? 11 is 1 less than 12. 11 is 1 less than twice 6. So those are shortcuts to get brother angles. And by the way, why does that make sense in the case of the pi over 6 family? All right, well, I'll bring up this picture again. Actually, what I'll do is I'll take this picture here. I'll shrink him a little bit. Shrink him a little bit. And I'll bring the computations up here. All right, there we go. Pi over 6. So that's our reference angle. It's acute. Reference angles are always acute by definition. 5 pi over 6. Why is this 5 pi over 6? Well, how do we get this angle? We go around half a revolution, that's pi radians, and then we backtrack. We go clockwise by pi over 6 radians. We subtract pi over 6. So to get this angle over here, what do? Pi minus pi over 6. Pi minus pi over 6. We want a common denominator. Pi is 1 pi. 1 pi is 6/6 pi. What is 6/6 pi minus 1/6 pi, which is what this basically says? It's 5/6 pi, or 5 pi over 6. The shortcut? 5 is 1 less than 6, because it follows this algebra. What about the 7 pi over 6? Why is he the famous brother in quadrant 3? Well, here I'm going to erase a bunch of this stuff. So here, for 7 pi over 6, we want the pi, half a revolution, plus pi over 6. We want to revolve counterclockwise a bit more, rotate a bit more. What's pi plus pi over 6? And I know students have trouble with fractions and pi, but think through it carefully. Pi is 1 pi, it's 6/6 pi. What's 6/6 pi plus 1/6 pi? It's 7/6 pi, or 7 pi over 6. Take it calm and steadily, you'll get it. Why the 11 pi over 6 in quadrant 4? If we want the positive angle and not, say, negative pi over 6, which is coterminal. All right, this time we want to consider not 1 pi, we actually want to consider, I'll put this in orange, we want to consider 2 pi. That's a full-blown 2 pi radians, a full counterclockwise revolution. And then we're going to backtrack. We're going to go clockwise by pi over 6, the reference angle. Remember, 30 degrees is pi over 6 radians. The reference angle is pi over 6 radians, or 30 degrees. What is 2 pi minus pi over 6? Let's do the algebra or pre-algebra. 2 pi is 12/6 pi. What is 12/6 pi minus 1/6 pi? It's 11/6 pi, or 11 pi over 6. So, maybe this is the Corleone family from The Godfather. What is the famous family of brothers with reference angle pi over 6 radians? Between 0 and 2 pi radians. pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. These might be the Corleones from The Godfather. 4 brothers. These are the famous brothers between 0 and 2 pi radians, where the reference angle is pi over 6. Okay, now what about the pi over 4 family? The Simpsons. What are the 4 famous brothers with reference angle pi over 4 between 0 and 2 pi radians? Follow a similar pattern. I'll give you a few moments. If pi over 4 is in the upper right, quadrant 1, who are the famous brothers in quadrants 2, 3, and 4, following this pattern? Go. All right, think you got it? Let's see. Pi over 4 in quadrant 1. 3 is 1 less than 4. 3 pi over 4 in quadrant 2. 5 is 1 more than 4. 5 pi over 4 in quadrant 3. 7 is 1 less than twice 4. 8. So 7 pi over 4 here. What about the pi over 3 family? The famous special angles between 0 and 2 pi radians with a reference angle of pi over 3. There are 4 brothers with that property. Go. Follow this pattern. All right, think you got it? Pi over 3, 2 pi over 3 here because 2 is 1 less than 3. 4 pi over 3 here. 4 is 1 more than 3. 5 pi over 3 here. 5 is 1 less than twice 3. 6. Now, it's really great that this trick works for pi over 6, pi over 4, and pi over 3. Actually, it doesn't work for other angles like pi over 5. Well, let me think about that for a moment. Pi over 5. Pi over 5. Actually, come to think of it, that would work. That would work for pi over 5, pi over 7, pi over 8, pi over 9, pi over 10. Actually, that would work. So for example, if this is pi over 10, 9 pi over 10, 11 pi over 10, 19 pi over 10. However, there is another trick with reference angles where actually it wouldn't work for pi over 5 or pi over 10. That's another trick I'll describe later in the chapter. But actually, this works for pi over 3, pi over 4, pi over 5, pi over 6, pi over 7, and so forth. All right. Coterminal twins, remember, have the same trig values, including the signs. So, for example, 5 pi over 3 is coterminal to negative pi over 3. They're going to have the same sine value, cosine value, tangent value, and so forth. But then, why is it that we care about these brothers or sisters or coreference angles? Even the ones that aren't necessarily coterminal in the same quadrant. Well, here's the thing. It turns out that all these angles in the same family, all these brothers, they're going to have the same trig values, the same sine value, the same cosine value, the same tangent value, and so on, in absolute value, meaning up to the signs. The trig values could actually differ by signs. Why do we care about brothers? Brothers have the same basic trig values up to, that is, except maybe for, the signs. In other words, the basic trig values between two brothers are the same in magnitude or absolute value. They can only differ at most by signs. All right. So we're going to talk more about this sign issue, SIGN, positive and negative, next time.